Hey future engineers and doctors, welcome to another exciting session where we unravel the mysteries of physics. Today we're going to dive deep into the fascinating world of circular motion and angular concepts. These topics are not just crucial for your GE and NEET exams, but they also form the foundation for understanding many real-world phenomena. So, buckle up and get ready for a thrilling ride through the realms of physics. Buckle up because we're diving into some mind-bending physics today. Circular motion and angular concepts might seem complex at first, but with the right approach, they can be as simple as riding a bike. Imagine the thrill of understanding how planets orbit the sun, how a car takes a sharp turn, or even how a figure skater performs those breathtaking spins. All these phenomena are governed by the principles of circular motion and angular concepts. Alright, let's start with circular motion. Circular motion is everywhere around us. From the smallest particles in an atom to the largest celestial bodies in the universe, everything follows the principles of circular motion. But what exactly is circular motion? Simply put, it is the motion of an object along the circumference of a circle. The object moves in such a way that its distance from a fixed point, the center of the circle, remains constant. Imagine you're on a merry-go-round. As you spin around, you're experiencing circular motion. Simple, right? But there's more to it than just spinning around. When you're on a merry-go-round, you're constantly changing direction. This change in direction is what makes circular motion so interesting and unique. Unlike linear motion where you move in a straight line, circular motion involves a continuous change in direction. As you spin around, you're experiencing circular motion. Simple, right? But let's break it down further. In circular motion, there are several key concepts that we need to understand: angular position, angular displacement, angular velocity, and angular acceleration. Each of these concepts plays a crucial role in describing the motion of an object in a circular path. Now, let's break it down. First, the angular position. Angular position is a measure of the angle at which an object is located on a circular path. It is usually measured in radians or degrees. Think of it as the position of the object on the circle at any given moment. For example, if you're standing at the 3 o'clock position on a clock, your angular position is 90 degrees or P2 radians. It's like the clock's hand pointing to a number. The angular position tells you where you are on the circle. But what if you move from one position to another? That's where angular displacement comes in. Angular displacement is the angle through which an object has moved from its initial position. It is a measure of the change in angular position. It tells you where you are on the circle. Next, angular displacement. Angular displacement is a vector quantity, which means it has both magnitude and direction. The magnitude of angular displacement is the angle through which the object has moved, and the direction is given by the right-hand rule. If you curl the fingers of your right hand in the direction of the object's motion, your thumb points in the direction of the angular displacement. Think of it as the angle you've turned from your starting point. For example, if you start at 3 o'clock and move to 6 o'clock, your angular displacement is 90 degrees or P2 radians. But what if you move in the opposite direction? In that case, your angular displacement would be minus 90 degrees or P2 radians. Angular displacement helps us understand how far and in which direction an object has moved on a circular path. If you start at 3 o'clock and move to 6 o'clock, that's your angular displacement. Now, angular velocity. Angular velocity is a measure of how fast an object is rotating. It is the rate of change of angular position with respect to time. In other words, it tells us how quickly an object is moving around a circular path. Angular velocity is usually measured in radians per second or degrees per second. How fast are you spinning? Angular velocity is a vector quantity, which means it has both magnitude and direction. The magnitude of angular velocity is the rate at which the object is rotating, and the direction is given by the right-hand rule. If you curl the fingers of your right hand in the direction of the object's rotation, your thumb points in the direction of the angular velocity. It's the rate of change of your angular position. For example, if a skater completes one full rotation in 2 seconds, their angular velocity is 2p radians per 2 seconds, or pi radians per second. But what if the skater speeds up or slows down? That's where angular acceleration comes in. Angular acceleration is the rate of change of angular velocity with respect to time. Picture a skater spinning faster and faster. Instantaneous angular velocity Instantaneous angular velocity is the angular velocity at a specific moment in time. It tells us how fast an object is rotating at that exact instant. For example, if a skater is spinning at a constant rate, their instantaneous angular velocity is the same at every moment. But if the skater is speeding up or slowing down, their instantaneous angular velocity changes over time. It's the angular velocity at an exact moment. Imagine freezing time to see how fast the skater spins right then. This concept is crucial for understanding the dynamics of rotating objects. Now, let's talk about average angular acceleration. Average angular acceleration is the change in angular velocity over a period of time. It tells us how quickly an object's rotation is speeding up or slowing down. Imagine freezing time to see how fast the skater spins right then. Average angular acceleration is how quickly your angular velocity changes over a period of time. For example, if a car speeds up from 0 to 60 radians per second in 10 seconds, its average angular acceleration is 6 radians per second squared. But what if the car's speed changes at different rates during that time? That's where instantaneous angular acceleration comes in. Average angular acceleration is how quickly your angular velocity changes over a period of time. Instantaneous angular acceleration is the angular acceleration at a specific moment in time. It tells us how quickly an object's rotation is speeding up or slowing down at that exact instant. For example, if a car is accelerating at a constant rate, its instantaneous angular acceleration is the same at every moment. But if the car's acceleration changes, its instantaneous angular acceleration varies over time. Like a car speeding up in a circular track, instantaneous angular acceleration is crucial for understanding the dynamics of rotating objects. It helps us analyze how quickly an object's rotation is changing at any given moment. This concept is particularly important in fields like engineering and physics, where precise measurements of rotational motion are required. And lastly, instantaneous angular acceleration. Just like instantaneous angular velocity, it's how quickly your angular velocity changes at a specific moment. For example, if a car is accelerating at a constant rate, its instantaneous angular acceleration is the same at every moment. But if the car's acceleration changes, its instantaneous angular acceleration varies over time. Just like instantaneous angular velocity, it's how quickly your angular velocity changes at a specific moment. Picture the car hitting the gas pedal suddenly on that circular track. The car's instantaneous angular acceleration would spike at that moment, indicating a rapid change in its rotational speed. Understanding these concepts is essential for analyzing the motion of rotating objects and solving complex physics problems. It's how quickly your angular velocity changes at a specific moment. Picture the car hitting the gas pedal suddenly on that circular track. The car's instantaneous angular acceleration would spike at that moment, indicating a rapid change in its rotational speed. This concept is crucial for understanding the dynamics of rotating objects and solving complex physics problems. Picture the car hitting the gas pedal suddenly on that circular track. Got it? Circular motion and angular concepts are just that simple. By understanding these fundamental principles, you can analyze and predict the behavior of rotating objects in various scenarios. Whether it's a car taking a sharp turn, a planet orbiting the sun, or a skater performing spins, these concepts are at the heart of it all. Got it? Circular motion and angular concepts are just that simple. Keep practicing and you'll ace those exams. Remember, the key to mastering these concepts is practice and application. Work on as many problems as you can, and try to visualize the motion of objects in your mind. This will help you develop a deeper understanding of the principles and improve your problem-solving skills. Keep practicing and you'll ace those exams. Stay curious, keep learning, and spin your way to success. Physics is a fascinating subject that can open up a world of opportunities for you. By mastering these concepts, you'll be well on your way to becoming a successful engineer or doctor. So keep pushing yourself, stay motivated, and never stop learning. Stay curious, keep learning, and spin your way to success. Remember, the journey to success is a continuous process of learning and growth. Embrace the challenges, stay focused, and keep working hard. With dedication and perseverance, you can achieve your dreams and make a significant impact in the world. See you next time. Until then, keep exploring the wonders of physics and stay curious. Goodbye.